Okay, so the first recording got corrupted. So I have to repeat. So I don't know why the pause it wasn't working. My OBS was a bit bugged, and when I have the explanation here, but let me do it again. Some reactions reach equilibrium. What do I mean? A normal reaction we could say, مثلا H2 plus O2 to produce 2H2O. Okay, قصدي no 2H2 like this hydrogen plus water as the hydrogen plus oxygen gets me water. Okay, easy reaction, blah blah blah. What if I told you there are some reactions, this is what we call, sorry, a complete reaction. Okay, it's complete. It complete in English means it finishes, right? It's whole. It's a reaction that finishes. But some reactions, for example the reaction SO2 plus half O2 to produce SO3, this is an incomplete reaction. Okay, incomplete reaction. And how do you write it? You don't put an arrow, you put another arrow that goes back like this. So you're going to see this symbol. This is called the equilibrium symbol. Okay, what do you explain to me? What does incomplete reaction mean? Incomplete in English means not finished, right? It's not a whole reaction. Okay, incomplete meaning it never finishes. So this SO2 plus half O2 is going to produce SO3. Why do you think I put this arrow that goes backwards as well? Because it can also go the other way around. It's a reversible reaction. As compared to the first reaction, which is irreversible, it can go back. This one here, it can go back. This SO3 can be decomposed into SO2 and half O2. Okay, what are these conditions called? This is what we call equilibrium. Okay, it's gonna keep on going left and right until it reaches equilibrium. There are two things. Okay, the definition of equilibrium is the constancy of macroscopic properties, okay, in a closed system. Okay, a closed system. What did you just say? Macroscopic are features that you can see. What are the three macroscopic properties like what are some macroscopic properties we can see? For example, color. For example, volume. Also, you could say pressure, temperature, blah 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 blah. So when you start to see that these stop changing, that's when you know you reach equilibrium. Walid, what's a closed system? A closed system is very easy. Anything that's a closed system, like he recognized a closed system. The definition from the book is a system containing a constant amount of matter with all this matter at the same temperature and pressure. What has closed? Okay, for example, مثلا, the reaction of let's say burning wood. Okay, combustion reaction. You could say burning ethene CH4 or whatever plus O2 to produce CO2 plus H2O. Okay, something like this. Okay, let's say so you're burning something with oxygen. Okay, if it's a closed system and it's closed and it's just these. However, if this is happening in a room filled with air, we know air has oxygen in it, right? So the oxygen from the air would probably play in and take part in the reaction as well. So hence, it won't be a closed system then because other matter is playing a role in the reaction. So is it a constant amount of matter if it's an open system? If it's an open system, that means there's matter from outside, so it's not a constant. Okay, this is just a quick overview of what equilibrium is. هلا we're going to teach you something called Le Chatelier. Okay, Le Chatelier, he's a French guy. I'm gonna use a different example now. Let's see, a bit of an easy reaction. Okay, Fe. Okay, yeah, this is the one they use a lot. Fe, okay, plus SCN minus. Okay, remember it's a two-way arrow. Okay, if in the exam for some reason in written you decide to put this, you're gonna get the whole thing wrong. Okay, make sure it's a two-way arrow. These are the new arrows we use now. So Fe plus SCN gets you FeSCN. Okay, this is a famous one they use in most of the questions. A scientist called Le Chatelier, or a chemist, he came and he said, oh, well, you can actually change the equilibrium. Okay, he said it's a statement, it's somewhere here, Le Chatelier's principle. Okay, it's when a system is at equilibrium, you change it, the system will partially counteract the imposed change. وليد يعني شو? Okay, Remember in grade 10, we took 5 factors that affect the rate of the reaction. The increasing the temperature, increasing the pressure if it's a gas, increasing the concentration, increasing the surface area, increasing adding a catalyst. These are all factors that affect the rate. Similarly, we have 3 factors that affect, okay, equilibrium. Equilibrium, I'm going to denote it by this. Okay, what are they? Temperature. Okay, I'm going to start with the easy one. Concentration. Okay. Temperature. Okay, and the pressure. So here's what you're going to do. What's the law? The law says that if equilibrium is subjected to a change, the system will work on counteracting that imposed change. مثلا, what are the things in equilibrium? It's a constant macroscopic properties, right? Macroscopic properties are constant, like volume, pressure, blah, 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 blah. So, مش صح if مثلا you decrease the volume of Fe, then there won't be equilibrium anymore, right? So what will the system do? It has to counteract to go against the change that you just put, which was decreasing Fe, and it's going to somehow increase the Fe again. So here's what happens. Let's start with concentration. Okay, we have 4 steps in the Chatelier. Okay, the first one is imposed change. Okay, 2 is to counteract the imposed changed. Okay, with 3, you say this is done by, okay, and then 4, you say final concentrations. Okay, so written part, you need these 4 steps, you write them, but for now I'm just gonna use them so you guys can understand better. Let's say مثلا I decided to lower the concentration of increase would be better. Increase, I wanted to increase the concentration of Fe. Okay, I don't need to write the charges now, I'm just trying to explain. So what is the imposed change? What are we changing right now? They said increase the concentration of Fe. So the imposed change is the increase in concentration of Fe. This symbol means concentration. Huh? So what will the system have to do to counteract this imposed change? What is the opposite? Counteracting, to go against it. What's the opposite of increasing Fe? We say the system, let me write in a different color. The system must decrease the concentration of Fe, right? Okay. هلا you're gonna say, Walid, how on earth are you gonna decrease Fe? Okay, let's say I have 1m, and I don't know, 2m. Okay, and we're reacting all of this, right? هلا I increase the concentration of Fe. It became 1.5 m, and these are all 1m, 1m. Okay, how am I gonna get rid of Fe? Okay, مش in the reaction here مثلا, aren't the reactants used up to form the product? They are, right? So technically, if I'm forming more product, more water, am I not using more hydrogen and oxygen? Yes, right? So in this case here, if I were to form more FeSCN, if I were to speed up the reaction, if I were to form more FeSCN, wouldn't I be using up my reactants Fe and SCN? Yes. So technically, to reduce the concentration of Fe, I can just tell the system to make more FeSCN, because when I make more FeSCN, that way I'm going to deplete, I'm going to use up my reactant Fe. So this is done by allowing the system to react, right? We want them to react to produce more FeSCN, right? Okay, so what happens now when I react getting more of this FeSCN? Aren't these two going to decrease? they're going to decrease. So basically, final concentration, what do you write? You just write what happened at the end. What happened? There are three things, right? We have Fe, we have SCN, and we have FeSCN. Okay, so my first one is Fe, my second one is SCN, بعدين عندي FeSCN, right? طيب ماشي. What happened? مش نحن we increased the production of SCN, we increased it. So that means the concentration of FeSCN increased. ماشي, and when we increased that, what decreased? These two, right? These two. So that means the concentration of Fe decreased وكمان SCN decreased. But it decreased. But did it decrease to the same amount as the original? No, it decreased, but Fe is still higher, slightly higher than original. Okay, this is how the Chatelier works. Okay, higher than original. Why? Because نحنا at the start didn't we add Fe? How is it going to go back to normal if we added Fe? It might go down, but it won't go down to the original. It will still be a bit higher than the original. But SCN will add the same thing. So this is the first thing, concentration. Okay, if you add something, we want to decrease that thing. Okay, and how do we decrease it? By allowing the opposite thing to produce more, to produce more of the opposite thing. That way this will be used up more. And same thing, let's say we added FeSCN. The imposed change would be the increase in concentration of FeSCN. To counteract that imposed change, we have to decrease FeSCN, right? To decrease FeSCN, what can we do? We can produce more of Fe and SCN. That way the FeSCN would be used up, okay, by allowing the system to produce more Fe plus SCN. Okay, and therefore the final concentrations would be increased Fe and increased SCN, but a decrease in FeSCN, but it would still be a bit higher than the original. So in simple words, the equilibrium can shift forward or backward. Okay, these are very important because 25, like most of the questions, okay, they ask if it goes forward or if it goes backward. Like now here, where did it go? It went to the FeSCN, right? It shifted to produce more FeSCN, so we say it shifted forward. But if it shifted to the left, that we say it shifted backward. So this is concentration. What about temperature? Okay, let's say Anna, same reaction. Okay, I'll erase it. Okay, وبعدين I say إنه delta H is مثلا in this case you're forming exothermic, so negative 25 kilojoule. Okay, this is an exothermic reaction, right? Let's say مثلا, let's erase all of this here. Let's do it one more time. Okay, here, move this. Okay, let's say now I decided to decrease the temperature. This is the imposed change. I decrease the temperature. أكيد the system has to do the opposite, right? It has to counter it. So instead of decreasing the temperature, what will the system have to do? It will have to increase temperature. Okay, this is done by what? Let's see. نحن we're decreasing the temperature. So it has to increase the temperature. There's two conditions. If we have two types of reactions in chemistry, exothermic and endothermic. Which one increases the temperature of the surrounding? Exo. Which one decreases the temperature? Endo, right? Remember, endo is when something becomes cold on the outside, and exo always releases heat. ماشي. نحن we know we want to increase the temperature. So we know that the forward reaction in this case, delta H is negative. That means it's exo. You know, when delta H is negative, it's exo. We know that the forward reaction is exo. And doesn't exo raise the temperature? Yes. So that means if I decrease the temperature, the system will have to increase the temperature. And to increase the temperature, it will have to go through the exothermic route. And isn't the exothermic route the forward reaction? Yes. So in this case, we're going to say equilibrium shifts forward. It's going to continue as normal because it is exothermic. Exo whatever. Okay. So let's say I increased temperature. Same reaction. Right? Let's say I increased temperature. Let me erase. Oh shit. Here. Okay. Let's say I increase temperature. أكيد to counter it we have to decrease temperature. How do we do it? Decrease temperature. What reaction decreases? Exo or endo? Endo. بسرعة you see endo. طب ماشي. You go to your reaction. طيب. Is the forward endo or exo? The forward is exo. بس أنا what do I want? And I want endo. So, do I go through the forward? No, the forward is exo. What do? I go backwards. If the forward is exo, يعني أكيد the backwards will be endo. So what will I do? This is done by shifting equilibrium to the backward, right? Backward because forward is exo. And then, by the way, the final concentration, guys, أكيد if it's going backward, what's going to be produced more? Fe is going to increase, SCN will increase, and this one will decrease. Okay, that's pretty self-explanatory. ماشي. هلا last thing خلصنا من temperature. Temperature is easy. Pressure is a bit more, it's a bit trickier, okay? It needs some focus here for pressure. Let's say it's the same thing. 1 and 2, it's the same thing all the time. Let's say we have two ways of increasing pressure, either by decreasing volume or increasing concentration. Okay, because you guys know if you decrease the volume of a container, like let's say this big balloon and this small balloon, which one has more pressure? This one, because it's a smaller space, so there's going to be more pressure. Okay, if you increase concentration, let's say you have this balloon and I put 1 mole of, I don't know, helium, and then I have the same balloon, but I have put 2 moles in helium here. Which one's going to have more pressure? This one, because 2 moles of helium, the particles of helium will start bouncing against each other and create pressure inside the container. Okay, so these are the two cases we can increase pressure, either by decreasing volume or increasing the concentration. Let's start by increasing the concentration. So I'm going to give an example just so you can help a bit understand. Okay, in this case here, let's say, I don't think these are gases. Let's actually use the SO example. Let's use SO2 plus, this is gas, half O2 gas to produce SO3 gas. Okay, well, I'm going to use the example actually for both of the pressure examples. Now we know pressure can be categorized by decreasing volume. To increase the pressure, we can either decrease the volume or increase the concentration of any reactant or product. In this case, let's say Anna, the imposed change is increasing the concentration of SO2. Increasing the concentration of SO2, okay, will increases the partial pressure of SO2, right? Since there's more of it now, more of them are going to start hitting each other and creating that pressure. So this is the imposed change. So obviously, to counteract this, we have to decrease the pressure of SO2, or in other words, decrease the concentration of SO2. So see, the partial pressure increasing the concentration to increase the pressure is the same as when we solved the examples that had to do with concentration. So okay, now it has to decrease the concentration of SO2, which in turn, when you decrease the concentration, it will decrease the pressure of SO2. Okay, so how will it decrease the concentration of it? Akid, we said when you want to decrease something, you increase the opposite side. Okay, so we're gonna increase. This is done by allowing the system react, shifting the equilibrium forward to allow yani more SO3 produced. For what are the final concentrations? Akid SO3 will increase, this will decrease, but it would be higher than the original. Okay, ماشي. How about Walid if you decrease the volume? If you decrease the volume of a reaction chamber, the P total, we're going to say V decreased. When you decrease the volume, the P total, the total pressure of the whole system increases, right? So to counteract this, we have to decrease P total, right? ماشي. What's part 3? How would we decrease the total pressure? It's a rule, memorize it, okay? You have to shift, the reaction shifts to the less gaseous moles. In this case, which one has less gaseous moles? The left side has 1.5, so 1.5 moles. The right side has 1. Which one is less? SO3. So where's it going to shift? In this case, shifts forward. Okay, and أكيد what will the final concentrations be if it shifts forward? More of this will be produced, so less of this produced, less of this produced. But there's not gonna be anything higher than the original because we didn't really play with the concentrations. In this case here, it's just gonna be this increases, this decreases, this decreases. ماشي. Like this كنا شرحنا equilibrium. Okay, before we go, there's a formula you have to memorize. It's called mass action expression. It's I'm gonna give you an example. Let's say A moles A moles of substance A reacts with B moles of substance B to produce C moles of substance C plus D moles of substance D. The mass action expression is equal to only for gaseous and aqueous. Okay, memorize this. Okay, the mass action expression is equal to the concentration of the products divided by the concentration of the reactants. So in this case, what will it be? What are my products? The concentration of C times the concentration of D divided by the concentration of A times the concentration of the B. But you can tell me, why did you put these small ones? Any coefficient beside that gas or beside that aqueous substance becomes the power. So for C, what's the coefficient of it? Small c, so this becomes this. D, what's the coefficient? D. What's the coefficient of A? B. Okay, you'll understand more when we get into the questions. Okay, just remember this is only for gases and aqueous. This is also called K equilibrium, which stands for equilibrium constant. Okay, equilibrium constant. There are three things. Okay, you have the equilibrium constant. When do you get the equilibrium constant? أكيد only at equilibrium, right? Only at equilibrium. Before equilibrium, we call it mass action expression, and كمان after equilibrium, we call it mass action expression. So when can we call it equilibrium constant? Only at equilibrium. At any other instant, what is it called? Mass action expression. Because these are all questions in the quiz. Okay, let's write. So يلا. How is the law of equilibrium usually written as? Okay, law of equilibrium K. البدون K, equilibrium constant. Let's see. We know that the equilibrium constant is equal to the concentration of the products divided by concentration of the reactants. شو عند products هون? Only for gases and aqueous. كلهم gases here, so it doesn't matter. So what is it, my product? It's CO2. So concentration of CO2 divided by concentration of my reactants. What are they? CO, concentration of CO, times concentration of O2. But there's a coefficient in O2, so what do we put it? Boom. You raise it up here to the power. That's it. بس هيك. Easy. See? ما بدها هالقد. Super easy. Memorize formula. Question 2. Okay. What is the mass action expression or reaction quotient, and when is it applied? Okay, when is it applied is very important. Now we know how to find the mass action expression. Easy. Products divided by reactants. شو بتكون? Products, concentration of the products, H2, I2. There's no coefficients, so we don't put any power, over concentration of HI. The first thing you check is if they're gases, but all of them here are gases, so it doesn't matter. Here, is there a coefficient for HI? Yes, so you raise it to the power of the coefficient. Okay, I hope you're understanding better now. So when is it applied? At equilibrium or at that instant? When do we say mass action expression? Do we say it at equilibrium? No. At equilibrium, what do we call it نحن? At equilibrium, we call it equilibrium constant. ماشي? So that's why we say this, Q equals this, at that instant. 3. Okay. Where this system, when will any reaction reach equilibrium? When all the NO2 change to NO, when something's fully used up? أكيد no. When changes can no longer be observed? Yes, right? When مثلا the macroscopic properties are constant, so we cannot observe any changes in macroscopic properties. For example, no more change in color. For example, no more change in volume between the two. No more change in pressure, no more change in temperature. One thing for both the forward and backward is equal, and that thing is the rate. At equilibrium, the rate of the forward is actually equal to the rate of the backward. Okay, oh yeah, it's actually here. I didn't see that one. Okay, when the forward reaction is equal to the reverse or backward. When the forward reaction is faster, أكيد لا. When the forward is slower, أكيد لا. Okay. Question 4. How long is this? 24 minutes. Let me try and finish. My phone's getting spammed. I wasn't able to record chemistry earlier. I was busy in the weekend. Okay. Which of the following will intensify the red color of the equilibrium? What's the red color? The red color is the product. So which ones here will favor my products? Which one will shift it forward? Let's see. The addition of FeNO3. FeNO3 is the same as adding Fe. Okay? But then they're trying to trick you. Okay? It's the same as adding Fe. So if I add Fe here, okay, I increase Fe. What does the system have to do to counteract it? It has to decrease Fe. How would you decrease Fe? By producing more products. So am I favoring the products here? Yes. What do we want in the question? We want the red color to intensify. So we want the products to be favored. Okay. The addition of water. في water بالequation ما في. انسى. The addition of KSCN. KSCN again, it's like saying adding SCN. Okay, adding SCN. They're just trying to trick you with the K. Okay. If you add SCN, you increase it. SCN. What does the system have to do to counteract it? It has to do the opposite, right? So it has to decrease SCN. How does it decrease SCN? That means we can do that by using up the SCN. What happens when we use up SCN? It makes more products, right? So doesn't that shift the equilibrium forward? Yes, forward. The addition of any OH. عندنا شي Na, عندنا شي OH, ما عندنا شي. عندنا شي HCl, ما عندنا شي. Okay, these two only. Question 5. Okay, what happens when Na2HPO4 is added? So for this one, many people were confused because the answer to it wasn't in the notes, wasn't in the book, wasn't in anything. But it's a rule you have to memorize. When Na2H2PO4 is added to this solution, it decreases Fe. Okay, it decreases Fe. And what should the system do to counteract the decrease of Fe? To counteract it should increase Fe, right? How would it increase Fe? By allowing more product to be used up back into reactants, right? That way, more Fe will be produced. But if more product is used up, that means FeSCN2 will decrease, right? And what will happen to the color? Akid, the deep red color will begin to fade away or diminish. People say diminish because we're decreasing FeSCN2. Will it increase FeSCN2? No, akid no. We said it will decrease. The red color will intensify? No, it will diminish because it's decreasing. The red color will diminish because we removed SCN? No, because the decrease of FeSCN2. This one here, not SCN. شو خاص SCN? SCN is pale yellow. Which of the following affects the equilibrium concentrations? 3 things. What are they? Temperature, concentration, and concentration again. Product, reactant. If they put pressure, كمان is correct. Or if they said decreasing the volume, كمان that would be correct. But they have to specify and say gas. Okay? If they said decreasing pressure, كمان they give you a solid solution or a solid reaction, then it's completely wrong. Okay? Be careful. They might do that. What will the addition of a catalyst do to a system at equilibrium? Catalyst will not change equilibrium. It's not one of our 3 factors, right? It will not alter it. But it will bring the system to equilibrium more rapidly, right? Because we know that the catalyst increases the rate of reaction. So it will be it will reach equilibrium fast. And what does a catalyst generally do? We know that it provides a new route with lower activation energy. We know that. Will it increase the rate in one direction? No, we know it increases the forward and the backward. And yeah, see, it increases both the forward and the reverse. Question 8. Let's go a bit quicker. Le Chatelier says that when a system is subjected at equilibrium, is subjected to a change, the system will partially counteract the imposed change. We know this, right? Okay, what is equilibrium constant expression for the reaction? We know equilibrium constant. Here they say equilibrium constant and not mass action expression anymore. Equilibrium constant is products, concentration of products divided by concentration of reactants. In this case, if you pay attention, my reactants are not gases, neither are they aqueous. They're solids and liquids. So do we write anything for my reactants? No. So it's just going to be concentration of my products, which are KOH قصدي, and H2. Are there any coefficients? Yes. So we put power 2. Okay, that's it. No reactants. No reactants. Question 10. There's 25 questions. Let's fly through these. What is the law of equilibrium here? Again, same thing. the solids ما بنحسبهم, only الأقوس gases, but it will be concentration of products divided by concentration of reactants. So in this case my products are, I'm not gonna keep writing it, it's gonna be Cu divided by concentration of reactants في Ag, بس إلها coefficient 2 فبتحطها power 2. Okay. Question 11. Again, law of equilibrium. So I'm not going to keep repeating myself. Concentration of products divided by concentration of reactants, but my reactants is non-gaseous, neither aqueous, so we don't write it if it's a solid or a liquid. Okay, yani concentration of this times concentration of this. You exclude the liquid. Okay. Okay, which is correct about equilibrium? Chemical reactions proceed spontaneously. Okay, yeah, this one I didn't explain it. Okay. At the start, before equilibrium, before everything, how do we know who does it favor? Okay, there's two things. A chemical, or let's say equilibrium, it favors two things. Okay, minimum energy and maximum randomness. Okay, maximum randomness. I apologize for the handwriting. Okay, minimum energy is which one has less energy. And that's it, just which one has less energy. So in مثلا an exothermic reaction, okay, wait, in an exothermic reaction like this one, SO2 plus O2 to produce SO3. Okay, at the start, who does it? This is exo because delta H is مثلا negative 25. Okay, this is exo. Which one has less energy in this case? أكيد, if it's an exothermic, you're releasing energy outside, and the products will have less energy. So that means it will favor the products. Also, maximum randomness means you have solid, liquid, gas. Which one is the most random? Gas. Which one is the second most random? Liquid. And the least random is solid. Why is it random? Because, in particles in the gas, they're all over the place. They're going in random motion, complete random motion. Okay, for what are the two things? Minimum energy, maximum randomness. Okay, equilibrium, it goes to either minimum energy and maximum randomness. It's a compromise. Okay, it tends to favor greatest randomness, and at very low temperatures, equilibrium favors only lowest heat content. Lowest heat content يعني minimum energy, least heat, least energy. Question 13. A system containing a constant amount of matter, okay, with all this matter at the same temperature pressure, is a closed, we know closed system, right? What type of system? It's either closed or open. أكيد if it's containing constant properties يعني closed. The factor that affects the value of the equilibrium constant is the temperature. And honestly, I didn't understand why this was the answer, but now after I searched it up, I kind of got it. Okay, if you increase the temperature of any reaction, it's either going to shift forward or it's going to shift backward. And if something shifts forward or shifts backward, right, it's either favoring the products or it's either favoring the reactants, right? Okay, if it's favoring the products, okay, we know that the equilibrium constant is products divided by reactants, right? If it shifts to the products, I have more products. I will have a greater equilibrium constant because I will have a higher number up here, right? So if it favors the reactants, what happens? If it favors the reactants, I'm going to have more reactants, so hence I'll have a smaller equilibrium constant. And why would something be favored? Because I'll be changing the temperature. If it changes the temperature, the equilibrium will shift in some direction. Okay, just memorize it. Okay, using the Chatelier's principle to predict the shift of equilibrium position, if the total pressure is increased, or the pressure is increased by what? Decreasing the volume. If you decrease the volume, P total increases. What did we say when P total increases? How do we counteract it? Yet we have to decrease the total pressure. How? We always said shifts to less gaseous moles. Okay, less gaseous moles. Let's see. Here we have, this is solid, we don't look at it. 1 mole, 1 mole. If it's 1, then will it change? No, no change. Here we have 2, 1. So here we have 3, here we have 2. Which one's is less? Here, so it's gonna go backward. Okay, here you have 1, 2, this is 2, this is 1, this is 3, this is 2. Which one's less? Forward, right? So it's gonna shift forward. Here you have 1, 1. Here you have 1, 1. So 2, 2. So equal, so it will be no change. Before the equilibrium state of reversible chemical reaction is reached, the rate of the forward decreases and the rate of the reverse increases. Okay, this is just memorize. This is the general explanation. Okay, so before you reach equilibrium, the rate of the forward will begin to decrease and the reverse will begin to increase until it reaches equilibrium, where the rates of the reverse and forward are equal, and the concentrations of the reactants and products are constant. Remember, at equilibrium, the concentrations are constant unless until you impose a change. When you say chemical equilibrium is referred to as dynamic, okay, it's called dynamic because it's two different things. أول شيء, you have two opposing microscopic processes that continue to take place simultaneously at the same rate with no macroscopic changes. Let me explain this word by word. Microscopic is small. Process is something that's happening. What are the small microscopic processes that we cannot see? أكيد the reactions. أنت can you see the redistribution of bonds in atoms? Until you can't see what's happening. That's how a chemical reaction occurs. Bonds are broken, bonds are formed, right? Okay, so we can't see it. So this is the microscopic processes that are occurring simultaneously, the forward and the backward. Those are the two processes, the forward reaction and the backward process that occur simultaneously, meaning at the same time. This came in the mechanics today. It said when is the both carts simultaneously at rest. I don't know why some people didn't understand what simultaneously mean and they got it wrong. صراحة it pissed me off because guys, grade 5 this is a grade 5 vocab word, simultaneously meaning at the same time. Okay, and these two processes, they occur at the same rate, right? The forward rate equals the backward rate with no macroscopic change. We said no macroscopic change, no change in temperature, no change in color, nothing, right? So let's see here. The reaction rate, the forward begins to decrease, the reverse begins to increase until they reach equilibrium where they are both constant at the same rate, constant and equal to each other. Okay, let's go. So long, man. Okay, 17. Okay, here we have once the effect of changing temperature using the Chatelier. Okay, here we have if it's changing temperature, you want to know if it's endo or exo. Here we know that it's endo. Okay, right? If it's in the reactant side and it's exo, you're absorbing the energy. If you decrease temperature, where would the equilibrium position go? Decreasing temperature, how would we counteract a decrease in temperature? We'll have to increase the temperature. How do we increase the temperature? What do we want? Exo, right? Is the forward endo or exo? The forward is endo. Do I want endo? No, I want exo. So that means I'd have to go backward. Since the forward is endo and I want exo, I have to go backward instead of forward. Because I don't want endo, I want exo. So it's going to shift backward. And what's going to happen to the concentration of SO3? If I go backward, what am I going to have more of? أكيد SO3. So the concentration of SO3 will increase. Okay. Here, temperature increases. Is this endo or exo? It's exo. Temperature increases. To counteract it, I have to decrease the temperature. How do I decrease temperature? What do I want? I want endo. Okay. Is this reaction exo or endo? It's exo. What do I want? Endo. So do I go forward or backward? Backward, because I want to do the opposite of exo, right? The forward is exo and I want endo, so I have to go the opposite of the forward. I have to go backward. I have to shift backward. And what will happen to the concentration of CO2 if I'm going backward? Don't be confused. This is CO, not CO2. CO2 is over here. CO2 is in the forward and I'm going backward. So akid CO2 will decrease. Okay. Question 18. What would happen if you add a catalyst on the following chemical reaction? Okay, if you add a catalyst to equilibrium, what happens? We know that equilibrium is attained faster. You reach equilibrium faster. And what would happen to the concentration? Would it change? No, we didn't say it affects equilibrium. It only makes it be reached quicker. So the concentrations will remain constant because it doesn't affect equilibrium. It doesn't make it change forward or backward. Question 19. If you add an inert gas, a noble gas, we know inert gases don't react. Okay, so simple, easy as. Since noble gases don't react, inert gases don't react, equilibrium position ما في أحلى من هيك. It is not affected. That's it. Okay, and everything remains constant. ولا كأنك you added anything. Not, it's as if you didn't even put anything. Okay. Ya Allah, I hate this SDP glitch. You go here. Okay, you go here. Okay. عندك هيدا reaction. Okay, if you remove Cl2, يعني you're decreasing the concentration of Cl2, how would the system oppose it? How would it counteract? It will have to increase Cl2. صح? How would it increase Cl2? It will have to move towards Cl2. So it's going to shift backward, right? We want more Cl2. So where's the system going to go? Again, it's not going to go forward because there's no Cl2 in the forward. So it's going to go backward towards the Cl2. And if it's going to go backward towards the Cl2, what's going to happen to SO2 Cl2? It's going to decrease because I'm going backward, right? If you add SO2, if you add SO2, so that means concentration of SO2 increases. If increase in concentration of SO2, how will the system counteract it? It will have to decrease the concentration of SO2. It's going to do opposite. SO2 is here. if I don't want SO2, I want to decrease it, where will I go? I will go where there's no SO2, right? I'll go the opposite way. So I'm going to go forward. So what's going to happen to the concentration of SO2Cl2? It's going to increase if it's in the forward. Okay. Okay. Question 21. Which of the following species will increase in concentration when B decreases? If B decreases, concentration of B decreases. That means to counteract this, the system will increase the concentration of B. Okay, when it increases the concentration of B, where will it go? It will go backward. So what else will increase as well as B? Akid A, because they're both on the same side, they're both in the backward. Ala 22. عندك هالreaction delta H is positive, يعني it's endothermic. If the pressure is increased, the system will counteract it by shifting. Okay, if the pressure of the whole system is increased, how will we counteract it? We're going to have to shift to the less gaseous moles. Okay, where's the less gaseous moles? عندي 2 here وعندي 3 here. Which one's less? Backward, right? So it's going to shift to the left or backward, whatever. What will happen to O2 and H2? Since we're going backward, should we see here? Akid, these will decrease. And the amount of H2O, what will happen since we're going backward and H2O is in the backward? Akid, H2O will increase. Okay. Question 23. عندك هيدا N2O4 to produce 2NO2, delta H is positive, blah blah blah. If the partial pressure of all gases is increased by decreasing the volume, so we're increasing total volume, what will you have to do? We're going to go to the less gaseous moles. Memorize it. You increase total volume, as you increase total pressure, to counteract it will have to decrease total pressure, and that is done by going to the less gaseous moles. Okay, so what will happen? Which is the less gaseous moles here? 1 or 2? 1. So it's going to go backward, right? Let's just say backward. Okay, if it's going to go backward, what's going to happen to N2O4? It's going to favor N2O4 because N2O4 is backward, right? Okay, how about NO2? NO2 is in the forward, but we're going backward, so it's not going to favor NO2. It's going to decrease NO2. Question 24. When temperature is increased in an endothermic reversible reaction, okay, they said strike through the incorrect term. Okay, this is habal, they're just saying select the opposite option, the wrong option. Okay, when temperature is increased in an endothermic reaction, okay, if you're increasing temperature, to counteract that, the system has to decrease the temperature, right? It's increase, this is increase. Okay, to decrease temperature, we want endo, right? And they said that the reaction is endo. So what will it do? Where will the equilibrium shift? If it's already endo, that means it will just continue as normal and go forward, right? Okay, so we know it's going to go forward. The concentration of the reactants, in this case, if we're favoring the forward, what will happen to the reactants? The reactants akid will decrease. Okay, but they said select the incorrect. So the incorrect one is increase. I don't know why. These questions are very stupid. And akid, the concentration of products, if you're going to the forward, this is the side of the products, right? This goes here, okay? This is the side of the products. Akid, the products will increase if you're going forward. But we said select the wrong option, so decrease. Okay. When temperature is increased, so we're increasing temperature in an exothermic reversible reaction. So we're increasing temperature to counteract that, the system must decrease the temperature. Okay, and how does we decrease the temperature? We said we want an endothermic reaction, but this is an exothermic reaction. So we have to, instead of going forward, what do we have to do to make it endo? We have to go backward now, right? We have to go backward. Okay, so what will happen to the concentration of the reactants? If you're going backward, and the arrow hon, you're going to go backward to the concentration of the reactants. What will happen? It will increase, but now we want the incorrect term, so we click decrease. Okay, and the concentration of products, okay, if you're going backward, what will happen to the products? The products akid will decrease, but now we said select the incorrect option, so increase. Last question, question 25. For any reversible reaction, the law of equilibrium can be stated as such: at equilibrium, the Q is equal to the equilibrium constant. Remember when I wrote this here? Only at equilibrium, the mass action expression is the same thing. Okay? But before and after, equilibrium constant is something completely different. Thank you so much for watching. I hope I didn't take too long. 45 minutes, that's reasonable enough. Good luck tomorrow.